will be encapsulating the message so that the attacker will not get into the message. Email can understand or can transmit only ASCII form of the data. The digital signature algorithm applied for both but with different keys. Hello students, welcome to the next session of network security. Let's start this session with the last protocol in the application layer, that is the MIME. What is this MIME? What is the S bar MIME stands for? What is the use of it? Let's look at that. The thing is, MIME is a security service. It is a security service protocol or the security service program that is designed for electronic mail, which is mainly used in email or electronic mail. The extension of MIME stands for the multipurpose internet mail extension. That is multipurpose internet mail extension. The S starts with secured. Okay, secured multipurpose internet mail extension is a service which is meant for the email. Okay, the protocol is an enhancement of the previous MIME. Previously it was named as just MIME. The advanced version was named as S bar MIME or secured MIME. Okay, let's know about this. Here we have the introduction to MIME. How does it is going to be used in a email service? Okay, here we have the users of the mail. One may be sender, one may be receiver. So how does it involves is, it involves the user or authority or the MIME we use, and we use the message transfer agent. Now we have the user agent, message transfer agent that we have discussed in the PGP. Along with that, we have an additional protocol, that is MIME. One of the limitation of the mail is that, or electronic mail is that, it cannot send a non-ASCII data like videos, audios and other text which are not in ASCII form. So for converting a non-ASCII data into a ASCII form, we use the MIME extension protocol, which converts a non-ASCII code to a 7-bit ASCII code. So this will be taken by the message transfer agent and will transfer 7-bit ASCII to the receiver or transmit 7-bit ASCII to the receiver. At the receiver end, what happens? Again, we have the message transfer agent in the receiver. So the message transfer agent takes that or transmits that 7-bit ASCII data again to the MIME protocol. MIME protocol converts it to non-ASCII code or non-ASCII data. It is converted to that, and the message will be read by the user agent. Okay, here we have the version of the MIME. We have 1.1 version of MIME. We use the content type, that is subtype, and the transfer encoding. So how does the encoding is done? Then the content ID or the message ID. Then we have the textual explanation of non-textual content. Suppose if the video is there, the audio is there. So to identify that file, there will be a content description. Along with that, we'll have the email body, which will be shown in a MIME header. This is the structure of a MIME header, not S bar MIME. This is the normal MIME structure, which has these many descriptions or parameters before it is used for converting the non-ASCII data to the ASCII form. When you discuss about the version of MIME, this header defines the version of MIME that is used. The current version we use is 1.1. So here we have the version number. Then we have the content type. What does the content type will tell? The content type and the content subtype are separated by a slash. We separate the type and the subtype along with the parameters. Depending on the subtype, the header may contain additional parameters that are needed to send a mail. Along with other types of data are there, non-ASCII data, then it will be specified in the parameters. Okay. So we have the set of data types and subtypes that are used in the MIME. So we have several parts. We have multi-part data types. In that we have mixed, parallel, digest and alternative data. So the body contains ordered part of different data types like integers or numerics, alphabets, all that. Then we have parallel type of distribution, data distribution, but you don't have an order for the data type. The next is the digest. We use the hash function to generate a message digest, which is similar to mixed one, but the default is message RFC 822. We use the RFC 822 protocol to generate a message digest. And the last category is we have alternate. The parts are different versions of the same message. So you'll have alternative representation of the same message. Okay. Then we have in message the RFC 822 part, the partial type and the external body type. So the RFC 822 will have a message. Body is an encapsulated message. We will be encapsulating the message so that the attacker will not get into the message. Then we have partial type of message. Body is of the mail is a fragment of a bigger message. When you take the external body, body is a reference to another message, like we use the hyperlinks in the mails. So that will be the external body. Then we have the image types supported by MIME is the JPEG and the GIF format. Image will be in JPEG format as well as the GIF format. When it is video, video will be in MPEG format. Okay. When you take audio, it will be basic single channel encoding of the voice is at 8 kilohertz speed. Okay. Then we have various applications if you want in the mail. You will have PostScript and octet stream formats. Okay. So we have Adobe PostScript that we can use and the general binary data that can be represented. Here we have a diagram which represents a Radix 64 conversion. What is this Radix 64 conversion is? It is included in the content transfer encoding part of the MIME, which converts the method used to encode the messages into 0 and 1. That is, converting to basic or binary format will be done by the Radix 64 conversion. This is one type of conversion. Apart from that, we have 7-bit conversion, 8-bit conversion, binary conversion, 7-bit, 8-bit, then binary conversion, the Radix 64-bit conversion, then we have quoted printable form of conversion. So we have these many conversions that can be done for the conversion from normal mail to the 0 and 1s format. Because the network only communicates or transmits the data that are in 1s and 0 form. Here we have the diagrammatic representation of the Radix 64 conversion. You can view here the blocks of 8-bit, 1 byte each, will be applied to Radix 64-bit converter. So this converter converts this non-ASCII data to ASCII form with a 6-bit. Okay, we use 6-bit of blocks, 51, 8, 4 and 57. So this will be made 8-bit non-ASCII data will be converted to 6-bit ASCII form of data by the Radix 64 converter. Then we are going to add the datas with non-zeros to form an 8-bit format. So we use the ZIE5 to convert it to ASCII form. We'll convert the 6-bit into ASCII form. So each 6-bit is converted to decimal. This decimal number represents each character in the Radix 64 encoding table. The first one was 51. 51 is represented as Z. Z will be taken and is converted to ASCII form. Then 8 is represented as I. I will be taken and is converted to ASCII form. Then we have 4 and 57. 4 is represented as E. So again it will be converted to ASCII form. Whereas 57 has the character 5. So we use the 5 to convert it to ASCII format, because email can understand or can transmit only ASCII form of the data. Non-ASCII data is converted to ASCII form using the Radix 64 converter. Okay. Then we have another format of conversion, that is quoted printable conversion. Here in the Radix 64 conversion, we have an overhead of bits in the header and the tail of the message header. So we have an overload. When there is the data which has most of the ASCII characters, only few of the characters are non-ASCII. In such an application, instead of adding or instead of using a Radix 64 converter with an overhead, we can go for the quoted printable conversion of the non-ASCII form to the ASCII form. Here we have the format. These are all in the ASCII format, but only this is not in the ASCII format. 100111101. Only this block of data is applied for the quoted printable algorithm. So this function will convert the message with mixed ASCII and non-ASCII data to the actual ASCII format. So this block is converted to the ASCII format with the different values, and it is again taken from this table to encode the binary information. So here we have the ASCII format of the data. This representation is converted to ASCII form, which represents the statement XL equals 9D9K. So you can represent this expression in the ASCII form like this. Okay. So this is the MIME that we have discussed. Let's go about the extension of MIME, that is S bar MIME. So S bar MIME adds some new content types. They add some new content types to include security services to the MIME. It is made more secure. MIME is made more secure with the improved version of MIME, that is S bar MIME. All of these new types include the parameter application packet with MIME. 7-bit conversion will be there, in which PKCS defines public key cryptography specification. So public key cryptography specification, which converts the normal message to the cryptographic message or cryptic message. Okay. Here, let's know about the cryptographic message syntax. What is the general syntax of the cryptographic message syntax? To define how the security services such as confidentiality or integrity is maintained, that can be added to MIME content type, isn't it? We know about the goals of the security. what we need. So it will be increased security as well as the confidentiality, integrity will be increased by adding a secured parameter to the MIME content types. Okay, where the S bar MIME has defined the cryptographic message syntax or the CMS. The syntax in each case defines the exact encoding. What exact encoding is? Encoding scheme for each content type. Each content of the mail will be applied to cryptographic message syntax, which converts the normal message to a cryptic form of message. For details, you can refer to the RFC 3369 and 3370 values or protocols. Okay, here we have a signed data content type of MIME. We have a signed with private key integer of 1, and we have another key set that is signed with private key of the signer n. If you take the signer as n, and we have the format of the MIME with signed data content type. Here we have the content, any type of content you can take. So this will be applied to hash algorithm. Whenever you apply hash algorithm, what you get is the message digest. So we get message digest in both the steps. Now we have the digital signature algorithm applied for both, but with different keys. So first message will have digital signature algorithm, which uses the signed private key from first signer. And we have another message that is signed with private key of another signer, that is n. We have two signers, 1 and n. It will be double ensured or double secured by using two different private keys and will be given to the signed data to be transmitted over the network. Here we have signature plus certificate plus the data will be added. We will say have set of packets that are signed and having a authentication certificate of the receiver. So it will have the contents and the sign and the certificate, which will be applied with the corresponding algorithms. Now we have another type, that is enveloped data content type. So here we have in enveloped data content type the encrypted packet with public key of recipient. This is with the recipient part. Then we have another packet signed with or encrypted with public key of the recipient n. We have two recipients, 1 and the n, and we have an encrypted session key with encryption. Okay, so we have the enveloped data content type. In this, we will get an object after the encryption, which is called as the enveloped data. What is the steps that can be happen in an enveloped data content type is, first, a pseudo-random key is generated by the key generator. So a pseudo-random session key is created and is sent as a public key by the receiver. So receiver's public key is used to encrypt the data. So here we have the encrypted public key of recipient n and recipient 1. So this will be applied to the data. Along with that, we use a symmetric key algorithm to encrypt a data. This will be sent as an encrypted content, and the content is encrypted using these algorithms, and we will get the information like recipient identification, public key certificate, encrypted session key. We'll have all these informations which will be converted by Radix 64 converter, which converts the non-ASCII form to the ASCII form and is pushed to the message transfer agent. From message transfer agent, it will be transmitted to the receiver. Here the method is pretty simple. In the digested data content type, the message will be applied with a hash algorithm to get a message digest. So this digest data or message digest data will be applied with the Radix 64 conversion. So this will be converted to ASCII data and we'll have the content. There is no encryption of the data like a key generator. That kind of data will be sent as a digested data content to compress the data. So you can have the digested data sent over the network by a mail server. So here we have another type, that is the authenticated data content type. In this, we use a MAC ID to use it to transfer to the receiver. What does the data will do or the MIME will do is, content will be obtained. It will be generated a MAC ID using the MAC algorithms for each recipient. We get a MAC content of the mail or the message. We use a MAC key to convert it. So here the content type is applied with a MAC algorithm to get a MAC data. This MAC data, before it is generated, is applied with the public key cipher with the recipients. If we consider 1 as a recipient and N as the recipient, each of the content is encrypted with public key of the two recipients, 1 and N, and will get a MAC content. So this MAC content will be having the MAC certificates, the algorithms, session key, all the things are involved, and together these are called as the authenticated ID data. This data will be forwarded over the network by MIME for the recipient. Okay. Here we have the cryptographic algorithms. The S bar MIME defines several cryptographic algorithms. The term must means an absolute requirement. The SMIME needs these cryptographic algorithms, whereas the should means the recommendation. Must is a required one and should is a recommendation. So here we have the content encryption algorithm, session key encryption algorithm, hash algorithm, digest encryption algorithm, and message authentication algorithm. Okay, the sender must support the triple DES format. In this, the RSA crypto system. Here we have the SHA1, and we use for digest encryption algorithm, we use the DSS. Then we use triple DES, RSA, SHA1, DSS. So receiver must support these algorithms, whereas sender can support a Diffie-Hellman alternative or RSA for digest generation. The receiver can use the algorithms AES and RC2 bar 40 or Diffie-Hellman for session key encryption, or MD5 for generating the hash algorithm or generating the hash function, or RSA for digest encryption. This is for digest generation and this is for digest encryption. So these sender and the receiver can use these different types of algorithm to encrypt the message and for generating the hash function or hash value. You can use different hash algorithms. Here we have an example. The following code shows an example of an envelope data in which a small message is encrypted using a triple DES method. This is the example that has been given for S bar MIME. With this, we have finished the concept of network security. Thank you.